Hey quad folks, today I'll be continuing the work on the TR-70B, the wiring harness and the backplane, reinstalling it into the converted TR-22 frame. As you can probably tell or see from these photos, that I took over the course of the first afternoon work, it was more or less 1 inch at a time. Move the frame, the back plane about 1 inch, and then rearrange the wires and make sure they're feeding through the proper places in the frame where they need to go, and then you move it another couple inches, and then you move all the wires around again, and so forth and so on. And after about 2.5 hours, I finally had gotten it, the back plane back into position to where I could put a couple of bolts through and bolt it temporarily into the frame and stand the frame back up on its wheels, right side up. And then we had to pack all the wires up in order to move it into the inside shop. And so today I spent the morning sorting and rearranging the wires into the general area that they're going to go, where they need to go. And this afternoon I'm going to be bolting in the front rails, and getting ready to bolt the module dividers back in between the front rails and the back rails. Well, this morning I spent the morning sorting and organizing the wiring harness and the general area that each trunk needed to go for the next step, of reassembly. So we're in all the wiring bundles and trunks are in the general area they need to be in now. And I know it looks like a big mess, and it is a big mess. But that's the old school RCA. Unlike, I guess, Ampex, where everything connected with usually ITT Canon aircraft connectors, we don't have any such thing here. Everything is hardwired, and so that means you have to unsolder wires in a lot of places, to get things apart. And that's a very long and time-consuming thing, considering how many wires is in one of these beasts. But the good news is every wire in this harness has a number. you can look that number up in the wire table in the one of the maintenance books and find out exactly where it comes from and where it goes to. So it may look like a big mystery, but it really isn't. There's just a lot of it. A very lot of it. The backplane itself, these are all gold blue ribbon amp connectors. Each one of these connectors is unique as it has a set of keys. See, there's a little dimple there. There's one there, one there. And then here, this one's in a different place. That one's in a different place. And that one's in a different place. And so all of these connectors, the surround on them is keyed differently. And there's only one module or one type of module that will plug into any particular socket. So you cannot accidentally plug a module into the wrong socket. A lot of damage would occur, you know, when somebody would maybe get confused or get in a hurry and try to plug a module in to a socket that it doesn't belong in. And of course that makes some damage, and of course after you damage it, it's not as good as it was, and it just gets worse from there on. On an RCA, they're solderless. I don't know how good this camera's focusing, so I hope I'm not. These gold on gold connections are not soldered to the connector. They're put in there with a little spring and a hammer device that drives it into that tapered connection socket. And they are so tight that you have to pull them out with pliers. They won't just come out. You wouldn't think that would be reliable, but I guess they're driven in under pressure. It's a tapered pin going into a tapered socket. And once it's in, and to pull it out takes some considerable force. Well, here we are, another day, wiring this old VTR. And when we left off, I think I'd pulled it in here and we had looked at a few things. Now, a few days later, things are getting a little more organized. We have our indicator shelf all bolted back on and the wires all plugged back in. And this part is important in that you really need to have this done before you put the overhead bridge back on, you know, because this is going to sit up inside the overhead bridge, although it's not to where you can't access it, but it makes it very much more challenging, you know, because you have limited reach and limited area to work, and you don't have any direct line of sight. And let me tell you, when you're trying to read all those little numbers on these wires and then find the lug that it goes to. That's kind of an important thing. You gotta have lots of light and, you know, but anyway, getting the harness back together, as it were, which entails mainly adding back the wire ducts, and then you know, pushing, pulling, reforming the wire into the harness. And sometimes it's one wire at a time, sometimes it's a bundle of wires at a time, you know. And this is not an Ampex. If you're familiar with the old Ampex VRs, those were all connectors. You unscrewed connectors and everything unplugged nice and neatly, and you take pieces out, you know, chassis, modules, came out as a whole unit. Not so with the RCA TRs. These were, you know, an earlier time, or the workmanship is from an earlier time, like the old school radio. Everything is point-to-point wiring, discrete components. These, you know, they're hand built, you know, on the frame. And you know, some ways that's good, I guess. Every wire has a number on each end, and they're also cataloged in the manual to and from list. So you know, you'll never get lost in a machine like this, even with all these wires, because you've always got a number on each end of each wire, and you can look it up in the book where it goes to or where it comes from if for some reason you can't read the number or the number gets chopped off. You know, and every corresponding pin on every connector is also in the book. So, you know, that's kind of nice in a way. When you are looking at an Ampex, for instance, a lot of the time you don't have that necessarily. If you pull a connector apart or look at a backplane, all you have are maybe color-coded wires, and sometimes you don't even have that. Some of them are all the same color, and they're not numbered. So if a wire gets broke off of a pin somewhere, you really have to look it up or trace it to find out and know exactly, you know, where it came from. Here you don't have to do that as much because of the numbering of the wires. But it is, I guess, kind of a lost art. I mean, nothing will ever be made this way again. You know, hand-wired point to point. That's probably a thing of the past. You know, if there's so much automation and printed circuit type things that have came along. But, you know, even the modules that's all hand built, point to point. So there was nothing automated about the construction and building of a TR-RCA. It's all handmade. And it's kind of sad, you know, in a way that that's not done anymore. It's anyway, what we have left now is what looks like a big mess here. These switch gangs and these little switching modules, they mount after we mount the overhead bridge up here. These switch gangs and the switching modules, they feed through these openings down into the lower front portion of the overhead bridge, where the light and the reflector is, and they mount on this hinged panel here. And so this, when it's mounted, it swings down, and then all the wires and the assemblies come through, and they're mounted out front here on this swing down panel, which we will put on after we put this part back on the frame. Then we'll reattach that and then pull the wires through and mount all the switches and circuit boards out front. And that's what this is. It looks like a big mess, and it is a big mess, but these are just waiting, you know, to be fed, picked up and fed through the overhead out front when we get it mounted back on. So it's like you do a little bit and you have to wait and put a few more pieces on, and then do a little bit more and wait again and put a few more pieces on. And that's kind of how this control unit went here. This thing was very intense, to say the least. The chassis, the lower board has to be inserted before you put the chassis in. And then after the chassis is in, then you can mount the sockets in the chassis. And then you can come back and then mount the lower control board, which is this part that mounts to a couple arms that extend out from this little card cage chassis. And so this is all one piece when it's in the machine. And this is the mode switching, you know, play, forward, rewind, all that. And these are all the actuating circuits, the drivers, you know, that drives the solenoids, relays in the machine to start and stop things. And if there's any old computer guys in watching this, you might recognize these driver logic boards are carryovers from the old RCA 501 computer system, you know, around 1960, around in there. And so some of that made it into the TR-22, which I think came out in 1964, I believe. Not sure about that, but somewhere in the early mid-60s when the TR-22 appeared. And this, by the way, this is a TR-22 frame that I adapted to rebuild the TR-70B into, because the 70B frame was very rusty and needed a lot of work. And the folks up at the MBT in Rhode Island was good enough to do a little trade with me. And so they traded me one of their old TR-22 machines, which was incomplete electrically, but the frame and the cabinet was all complete, which is the part I needed. I didn't really care that much about the electronics because I wasn't ever going to revive a TR-22 anyway. Although a lot of the components in a TR-22 are used in a 70. So there are a few good spare parts, you know, in one form or the other out of a 22 that, you know, you can use to maintain and repair a 70 or a 70B with. Not so sure about a 70C. There was a lot changed in a C. And so there's probably a few things that would. So I guess the next step along this little job is while I'm waiting on some help to lift up the monitor bridge back onto the frame here, we do need to reinstall the module cage for the video side, or the video output, I should say, video and audio output over here. And that side on the left is the video and audio input. So you have audio, video, and Q in. And over here you have audio and video and Q out. So that'll be the next little step, is to reinstall this module cage for the output. And in doing that, we need to sub out the lower part from the 22 and replace it with the 70, the lower part. So the readout will be correct. That's the only difference, is the readout. And I really don't want to try to pry that off and re-glue it to the existing one, because something will probably get bent or broke. And since I have the other one, I'm just going to replace the whole thing and be done with it. Let's see, one other, I guess, major difference between a 22 and a 70 was, this is the 22, the back of a 22's the module cage. And the 22, they had threaded holes, and they screwed the connectors directly in to back of the cage. Now they weren't screwed in solid. They had a little bit of a play in them, you know, left or right or up or down. But they didn't have any in or out. So when you slid a module into a 22, if everything wasn't just exactly lined up, you could do some damage to the connector, you know, because the screws, that was a hard mechanical connection there that didn't give much. And what they changed when they went to the 70 was they added springs. And let's see, how's a good way to demonstrate that? Well, let's look over here. I haven't changed this side over yet. Now, this is the 70. So they had a whole little frame that they mounted the connector on using a spring and a little shaft and a little compression pin. And you had a lot of give, you know, because if you were pushing in a module, you know, and it would self-align as you pushed it in, and they got away from that problem of smashing connectors. And also this spring, the front of the module latches on the lip of that lower front piece of the module cage, that little step right there. And so that it drops down and latches on that little step down when it's fully inserted. And that puts pressure against this connection back here. And so this spring is pushing against the connection, you know, under spring tension, so it holds it a lot tighter than the old way, you know, that the 22 had used with just a captive screw. There was no tension there. It just slid in, and that's all it did. Wherever it stopped, that's where it stopped. With this modification to the later 70, when it stopped, it was under spring tension pushing against that connector. So it was fully inserted and under pressure tension at all times. It's a much tighter connection because of that. So what I did here, since this hole in a 22 is somewhat smaller than the original 70, then you can't really use the little frame that was used in the 70 on a 22 without taking the frame off. And if you notice, this hole and this little cutout here is basically the same thing you have here in the 22. The only thing the 70 had was they had an extra set of holes for mounting the springs. And so the little workaround here was instead of using that extra frame, was when I mounted the connectors back into the old 22 cage, I used the springs and some long screws, 440 by 1 inch screws, that's a 440 thread. And so we get the same effect now. we have spring tension, and you see we have a little bit of a gap there between the connector and the frame. And so this connector is fully seated under spring tension against the module's connector. So we have the same effect that you would have with the 70 arrangement, only modified slightly to fit the earlier 22 cage. And so I thought that was kind of neat. I was able to do that without cutting anything or drilling any holes and get the same result. And so hope I haven't bored you too much with all my ramblings about connectors and connections and springs and cages and modules. But there are some subtle differences between 22s and 70s when it comes to, you know, cabinet parts and assembly arrangements. And I don't know if this is ever going to be important to anybody, but at least now you know the difference, some of the differences.